What are limits in mathematics? We have already seen about the concept of dy by dx equals to limit h tends to 0 f of x plus h minus f of x by h. This is called as first principle. We have derived this concept of first principle in the previous video. When I say that h is approaching 0, I can approach my 0 value in two ways. I can approach this 0 either from right hand side or either from left hand side. If I approach this 0 value or any value from the right hand side, it is called as right hand limit. So when we approach this 0 from right hand side, we need to apply this right hand limit. If I take my value 0 here, I can approach 0.0001 or 0.000001. In this manner, I can go to n number of values closer to 0. Similarly, if I approach from the left hand side, I need to apply the left hand limit. I can get the values like minus 0.00001, minus 0.000001, and so on. If I approach in this manner, whatever the value of limit I am going to get here, while approaching from left hand side and from right hand side, they should be equal. Then only we can say that the limit here will be existing. And that is why we have two limits, left hand limit and right hand limit. For this left hand limit, h tends to 0 minus. We call it as 0 minus, but it is not equals to minus 0. The notation 0 minus just indicates that I am approaching this 0 from left hand side. That's the meaning of that. Limit h tends to 0 f of x plus h minus, or I can just directly write that limit h tends to 0 minus f of x is a function. And right hand limit equals to limit h tends to 0 plus. The meaning of 0 plus is that I'm approaching my limit from the right hand side, f of x. To understand this, let us take an example here. If I take limit x tends to 2, x square minus 4 by x minus 2. Now if I apply the limit, what I get is 0 by 0 form. But I can just solve this by applying some mathematical formulas here. Limit x tends to 2, I can write that x square minus 4 as x plus 2 into x minus 2 by x minus 2. These two can be cancelled out, and now I can apply the value of 2 exactly. Now here I am saying that x is tending towards 2 value. If I take exactly x equals to 2, there is no problem here. So 2 plus 2, which is 4. We have the problem only when we have something by 0. So to avoid this 0 in the denominator, what we do is we just make that x is approaching towards 0 or the corresponding number. Limit x tends to 0 mod x equals to, we know that mod x equals to x for x more than or equals to 0, and mod x equals to minus x for x less than 0. If we apply left hand limit will be equals to limit x tends to 0 minus mod of x, that equals to limit x tends to 0 minus mod x equals to minus x For x less than 0, the function is defined as minus x for mod x, that equals to 0. If I apply x equals to 0 here, it becomes 0. Applying right hand limit, RHL equals to limit x tends to 0 plus mod x, that equals to limit x tends to 0 plus x. For x more than or equals to 0, mod x equals to x. On applying the limit, I'll get 0 as the value. If we see here, my left hand limit equals to right hand limit. LHL is equals to RHL. Hence the limit of mod x, limit x tends to 0, mod x is equals to 0. This is how we need to solve for mod function. But if I take the function like limit x tends to 0 mod x by x, so this is, if I apply left hand limit first, limit h tends to 0 minus mod x by x, that equals to limit h tends to 0 minus, my mod x is minus x for less than 0 values, so it becomes minus x by x. X gets cancelled and I get minus 1. My left hand limit here became minus 1. If I apply right hand limit, RHL equals to limit h tends to 0 plus mod x by x equals to limit h tends to 0 plus, for x more than or equals to 0, my mod x is x, so it is just x by x. These two gets cancelled and it equals to 1. My right hand limit is approaching towards 1 and my left hand limit is becoming minus 1. LHL is not equals to RHL. So for this, the limit doesn't exist. Limit h tends to 0 mod x by x does not exist. For whatever the values we take for mod x by x function, the limit doesn't exist. Let us try to understand this graphically even. If I draw the graph of mod x by x function, it will be, so let us give the input of mod x here. I'll give input as mod x function. I want mod x by x, so mod x by x. This is the function of mod x by x here. As my x values tends towards the 0, if we approach from the left hand side, if I approach from left hand side like this, from here to here, I'm going to the value of minus 1 here. But if I approach from the right hand side here, I'm going towards the plus 1. So these 2 points are different here. If I come from left hand side, I'm going towards minus 1 here, and if I come from right hand side, I'm going towards the plus 1. These two are not equal, so my limit doesn't exist here.